Critical infrastructure has traditionally been designed around a familiar assumption. Humans operate the systems. But that assumption is changing. Autonomous AI agents are beginning to interact with applications, APIs, workloads, and operational processes. These agents don't simply analyze information, they can act. This is the emerging machine identity problem in critical operational environments. For decades, cybersecurity architecture has relied heavily on boundaries. Firewalls determine which systems can communicate. Segmentation limits reach. Remote access controls determine how systems enter sensitive environments. Source, destination, service, protocol, policy matched, connection allowed. But what happens when the system crossing the boundary is already trusted? Consider an AI operations agent. It monitors equipment, it reviews alerts, it queries asset data, it creates maintenance requests. To perform useful work, autonomous agents require access, and every legitimate permission expands what that agent can potentially reach. Access creates capability. Capability requires boundaries. Humans operate at human speed. Autonomous software can evaluate and execute actions far faster, continuously and in parallel. Now consider what happens when the context around that agent changes. An untrusted instruction source, a compromised token, a modified dependency, a policy misconfiguration. The identity may still be valid, the workload may still be recognized, the network connection may still match policy. But the behavior has changed. The firewall may be doing exactly what it was configured to do. The firewall didn't fail. The trust model did. The agent doesn't necessarily need to defeat every network control. It may simply use relationships the organization already permits. Application, engineering service, workstation, jump host, control environment. At every boundary, the network path is allowed, while the trust context quietly changes. In enterprise IT, compromised access can threaten information and business operations. In operational technology, digital actions may eventually influence physical processes. Availability, operational continuity, and safety change the consequences of trust. Industrial security frameworks such as IEC 62443 emphasize segmentation through zones and controlled conduits. Nest Zero Trust architecture shifts the security question beyond network location alone. Explicit verification, least privilege, assume breach, context, policy, continuous evaluation. CISA Zero Trust principles extend the same thinking across the whole organization, not only the network layer. Modern infrastructure no longer contains only human identities. Users, devices, applications, workloads, services, APIs, AI agents, and operational assets. Autonomous systems add another dimension. Authority can now be delegated between machines. Who is authorized? To do what? To which resource and under which conditions? Authentication answers only part of the question. Conditions can change long after access is granted. Trust can instead be evaluated using identity, context, policy, and behavior throughout sensitive interactions. That leads to 5 boundaries for autonomous agents. First, every autonomous agent should be individually identifiable. Second, authority should match the task. Reading telemetry is not the same privilege as modifying control logic. Third, delegation should never silently expand authority. Fourth, a valid identity does not require unlimited trust. Fifth, a compromised identity should not automatically become a pathway across the environment. This is the type of security challenge QuantLayer is designed to address. QuantLayer brings identity, telemetry, policy, and segmentation together across heterogeneous environments. Every user, every application, every device, every network, every AI agent, every workload, each protected by its own cryptographic DNA. Each digital actor can be treated as a distinct security entity rather than simply inheriting trust from network location. Identity, continuous telemetry, policy and trust, enforcement, and response. So, return to the original request. The network connection can still be permitted, but the requested action falls outside expected authority. The destination is a sensitive operational resource. The behavior is anomalous. The delegation was never authorized. The credential can remain valid while the requested action becomes unacceptable. Trust isn't inherited forever. Security teams need visibility into the identity behind an action, the authority being exercised, the resource being requested, and the relationships connecting them. The objective isn't simply to generate another alert, it's to understand trust. Autonomous AI does not make firewalls obsolete. It changes what must surround them. Network boundaries still matter, but network location alone cannot define trust. As autonomous systems become more capable, enterprises will need to govern not only human access, but machine authority. The next generation of cyber risk may not arrive looking like malware. It may arrive with valid credentials, through approved applications, across permitted network paths, and from systems the organization already recognizes. So the question is no longer simply who authenticated, but what are they authorized to do right now? Secure every identity, define every boundary, continuously verify every interaction.